Okay, hi guys. Happy Friday. I'm going to work on the day 5 warm-up with you. Reading the directions. Simplify each expression without using negative exponents. Key thing here, no negative exponents. Okay, looking at our first one, we've got 3 to the 6th times 3 to the 7th. I see the same base, which tells me I'm going to want to add my exponents. 3 to the 6th plus 7 is 3 to the 13th. Plugging that in, I end up with 3 caret key 13, or 1,594,323. Now, like I said in days past, if it's over a million, you don't have to write it. So I would be fine with 3 to the 13th power. Next one, I've got 3 different variables. I'm just going to match them up. M to the 5th and M to the 9th will go together. N to the 35th and N to the 6th. And then P to the 6th, P to the 33rd. Okay, so for our m's, I see the same base. We're going to add our exponents. We're going to m to the 5 plus 9. I'm not going to show the work for that for time's sake. 5 plus 9 gives us 14. Our n's would be n to the, 37 plus 6, or 43. And our p's would be p to the 6th times p to the 33rd, or p to the 39th. Now the order of these doesn't matter. It could be p to the 39th times n to the 43rd times m to the 14th. As long as they're there, we're good. Okay, next one's very similar. Be careful with these coefficients. This is just saying negative 6 times negative 12 to make 12. I'm going to pair up my m's. M to the 3rd times m to the 7th. Since they have the same base, we will add them. And then n to the 4th, and that n, that's like an n to the 1st. Therefore, we get n to the 5th. Okay, moving on to our next one, we have a power to a power, which tells us we will multiply. X to the 4th times 6 gets us x to the 24th. Similar approach for number 5. That it's not the distributive property, but we're going to multiply this out. It's like distributing. We'll get x to the 30th because it's a power to power, and y to the 24th. Remember, we had one base, and it's a power to power, which is why we multiply. Next one is a lot trickier. I'm going to kind of pretend that this isn't here for a little bit. I'm going to deal with that negative 2x to the 7th, y all to the 3rd. And once again, I'm going to multiply that out. Negative 2 should go in parentheses, cubed. X to the 7th to the 3rd, we multiply to get x to the 21st. And then we'll have y to the 3rd, since that exponent was a 1. And I don't want to forget about what I had there, so I'm just going to have times parentheses, whatever it was. Simplifying this out, negative 2 to the 3rd gives us negative 8. X to the 21st, y to the 3rd. And now I can worry about what else was there. Times that negative 3x, y to the 9th. Now we're back to the last type of problem, or excuse me, back to like number 3. Negative 8 times negative 3 makes 24. Our x's have the same base. That x in blue is a base of, or an exponent of 1. Therefore, we get x to the 22nd, and y to the 3rd, y to the 9th gets us y to the 12th. Feel free to pause this at any time if I'm going too fast. Okay, 6x to the 0. I know your first instinct is to say 1, but be careful. This is really 6 to the first power times x to the 0, which is 6 times 1, or 6. Okay, number 8, our direction said no negative exponents. Well, if you need to, think about that as over 1. It's negative in the numerator, which tells us it has to go to the denominator. I have to put a 1 in my numerator to represent the upstairs. And now I've got 1 over x to the 6th. Number 9, be careful with as well. As I was checking your homework last night, we were struggling with this one. It's not 1 over 4x to the 4th. It starts out as 4 to the 1st times x to the negative 4th, which tells me the only part that needs to go to the denominator is the x to the negative 4th, leaving us with 4 over x to the 4th. Okay, similar problem for number 10. 5 is to the first power, x is to the first power, therefore they're okay. That y to the negative third needs to come up though. And we'll have 5x y to the third. Feel free to pause it if you guys need it. Okay, now moving on to our war like yesterday, we've got 8 to the 3rd over 8 to the 6th. Well, the denominator has 6, which is more than the numerator. Therefore, we're going to keep our base and we're going to subtract away from the bottom. But we must show that there still is that top. So 1 over 8 to the 6 minus 3. 1 over 8 to the 3rd, since the denominator 1. And I wouldn't necessarily put 1 over 8 to the 3rd in my calculator, because then I'm going to have to change it from a decimal to a fraction. I'd instead just do 8 caret key 3 to get 512. And I'll make sure I have that as 1 over 512. Same thing for number 12. 2 to the 15th over 2 to the 7th. Going to war, top wins. I don't have to worry about showing that there is a denominator, so I'm just going to say 2 to the 15 minus 7. Comes out as 2 to the 8th. Plugging that in, 2 caret key 8 gives me 256. Okay, number 13, x to the 4th over 2 all to the 5th. Well, we're going to kind of like distribute that power of 5. It's a power to a power, so we get x to the 20th over 2 to the 5th. Leaving us with x to the 20th over, well, 2 to the 5th, 2 caret key 5 is 32. They don't have same bases, that is our answer. 14, I would say, is a wall problem. I'm going to draw my wall as best as I can. And now I'm going to think about it as two separate problems. A to the 3rd over a to the 10th. Well, I have more men in the bottom, therefore I'll have 10 minus 3, or a to the 7th, left after war. I might have to put up a 1 up top to show that there is a numerator, but let me simplify the next part. B to the 6th over b is like b to the 6th over b to the 1st. top wins, therefore we're left with b to the 5th. I cannot do anything more because they are different bases. Okay. X to the 7th times 1 over x to the 11th looks tricky, but I'm just going to make that x to the 7th over 1. Then I know numerator with numerator, denominator with denominator, which gets me x to the 7th over x to the 11th. Now we're back to just a war problem. 7 men up top, 11 on the bottom. Bottom wins, so I'm going to have to show that there is still that numerator. And then if I take 7 from 11, I get x to the 4th. 1 over x to the 4th. Many ways of doing 16. So please don't think that if you don't go my route, you're wrong. There's, like I said, a lot. What I would choose to do first is to simplify within. I know that if they go to war, I'll be left with 1 over b to the 5th to the negative 1st. You know what I like to do whenever I have a fraction raised to a negative? I like to take the reciprocal, and that turns into b to the 5th over 1. And once I take that reciprocal, my power becomes positive. You could have also distributed, per se, that negative 1 to each, and then had to flip things around. But anything to the first power is not going to change, and I'm going to get b to the 5th over 1, which is the same thing just as b to the 5th power. Like I said, many ways of going about that problem. Once again on 17, many different ways of going about this. I'm going to just deal with my top. M to the 2nd, m to the 9th, that is a product of powers. Well, they have the same base, therefore I add 2 plus 9 to make our m to the 11th over m to the 6th. Now we're in a war situation. Top has more men, and we'll be left with m to the 5th power. Okay, 18 is tricky. That 4 is to the 1st, 4 is to the 1st. Power to power will give us 4 to the 3rd, x to the 9th, y to the 21st, all over 4 to the 2nd, x to the 16th, y to the 16th. Now you're welcome to simplify 4 to the 3rd over 4 to the 2nd, but they have the same base, so I'm going to just use our exponent rules. I'm going to think about this as 3 separate problems with the wall. And when I see 4 cubed over 4 squared, I see that top wins, leaving me with 4. X to the 9th over x to the 16th, bottom wins, leaving me with x to the 7th. And y to the 21st over y to the 16th, top wins, leaving us with y to the 5th. And number 19. Okay, like I said yesterday when we learned this, many ways of going about this. Here's one. Numerator with numerator, denominator with denominator. 4 times 15 is 60. X to the 4th times x to the 2nd. They have the same base. I'm going to add the exponents to get x to the 6th. That y is to the 1st times y to the 7th will make y to the 8th. Same thing goes for denominator. 8 times 5 is 40. Nothing to combine here, so x to the 10th y to the third. This is a Walls problem now. Well, right away, 60 over 40, I see that the zeros cancel out, and I'm left with 6 over 4. Well, that's not simplified. Each can be divided by 2 to give us 3 over 2. X to the 6th over x to the 10th, well, bottom wins, leaving us with x to the 4th. And finally, y to the 8th over y to the 3rd, top wins with y to the 5th left over. 3y to the 5th over 2x to the 4th. And finally, that 2 is to the first power, y is to the first power. This will now be a 2 to the 4th, x to the 12th, y to the 4th, z to the 24th. Two to the 4th simplifies to 16. We still have x to the 12th, y to the 4th, z to the 24th. None of these have the same base, which means we don't have to worry about going to war. And there is our simplified answer. Okay, good luck on your quiz. Please try your best. Have a great weekend, and I will see you guys on Tuesday.